can you write the electronic configuration? There is a difference between electronic configuration and octet configuration. That was discussed in detail in that video lesson. You better go through that. So why I'm putting all these recorded videos means you can just do repeat again and again. Because the class was given once means you could not able to grasp every point in a minute, in an hour or something. Okay. So you can utilize this recorded videos for your better revision. Okay, ma? Okay.
Okay.
So 11. So how can you write the electronic configuration? So that is different. That was
281.
yeah, 1s2, 2s2, 2p6 like that. That was clearly explained in that video. You can go through it. Okay. Now I'm going to convey the very simple and shortest method, that is octet configuration. You know, atoms having its own stability. Like we are walking by our legs, not by our head, right? Likewise, atom also having its own stability. What is its stability? It should contain 8 number of electrons in its outermost. Then only the atom is said to be stable. So we are considering inert gas elements, right? Argon, krypton, xenon. Okay, so these elements are, okay, so for example, group 18 elements, right? These elements are said to be inert gases. Why it is known as inert? It is having the inability to mingle with some other atom. That means it is fully stable. If one thing is fully stable, then we can able to say that is at complete rest. It won't mingle with some other atoms. Okay, so it is completely inert. Okay, ma. So the atoms tends to react with some other elements or some other atoms. Definitely, it should lose or gain electrons. Suppose atom's stability is to maintain, so it tends to maintain its stability always. But all the inert gas elements are inert. It does not react with, okay, because it is already having 8 number of electrons in its outermost. Some elements which is not having that much of element, that much of electron in its outermost, then that is said to be, it may lose or gain electron based on its outermost number of electrons. We can't say, we can say the outermost number of electrons as the valence. What is the valency? The number of electrons present in the outermost shell or outermost energy level. Okay, so that is valency. Suppose if you consider the valency, that valency can also be determinable based on the number of electrons in the valence shell. We can able to judge whether the atom can lose electron or gain electron. Okay, so I'll explain to you. See, for example, sodium atom, it is having 11 number of electrons, so atomic number. Okay, ma. So this atomic number we can write 2, 8, and 1. This is the octet configuration. So this is easy and understandable. So 11 number of electrons, we had to split. There is no other go. Only 2 electrons can be accommodated in the first energy level. Only S level are available. So more than 2 electrons cannot be accommodated in that. So less than 2 electrons can be accommodated. Understood? So in the second level, 8 number of, you know, right, the maximum number of electrons in each and every orbit is 2n square.
Yes.
So that 2, 8, 18, like that it will be going. So for octet configuration, we will write 2, 8, almost 8, 8, 8, 8. You need to write like that. Okay, so it comprises 2, 8, 1. So the third orbit is the outermost orbit. So third orbit is the outermost orbit. So this one will be the outermost electron, we can say. So this is the valency. So the valency of a sodium is 1. What is the atomic number for calcium? 20.
20.
Right? Yeah. How can you write this? 2, 8. Then 8. Then what is the remaining, ma?
282.
2. So what is the valency of calcium now? 2. Okay. So what is the atomic number of chlorine? 17.
17.
Okay. So how can you write? 2, 8, 8 and 1. Is it correct or not?
Yes, ma'am.
Is it correct? Hey, I got you, man. I got you. Physically present. Am I boring you?
Yes, no.
So how can you write? What is the next one coming? 17.
Weight 7.
Yeah. So what is the valency of chlorine?
3.
No, 7. The outermost, the number of electrons present in the outermost orbit. So that is valence. Can you able to understand?
Okay.
Clear? See, for example, we talk about the valence shell. Valence shell means what is that, ma? Outermost. So if the valence shell is containing, okay, so 8 number of electrons, it is stable. Half filled also said to be stable. Example, carbon, right? So, and then 8 is, argon, xenon, krypton, like all inert gases, okay? So, and then what is the next one? We can say less than half filled, and this is said to be half filled, and greater than half filled. Caleb, if you're not understood, let me know, I will repeat, okay?
Okay.
So less than half filled means those atoms have a tendency to maintain its stability, octet configuration. It may lose electrons. It has the tendency to lose electrons. Get my point? Do
Yes,
write
ma'am.
do write in your paper the atoms. Make it fast. The atoms have a tendency. Write in your own words so that you can able to understand. Okay, don't write all these was the everything. So atoms have a tendency to lose electron when it is having less than half filled in its outermost. When it is having less than half filled in its outermost shell, or in its valence shell. Less than half filled in its outermost shell or in its valence shell. Clear? So can you able to judge how many number of maximum electrons can be lost from an atom?
4.
No. So what is the half filled, ma? How many number of electrons in half filled? No.
That's
4. 4, right. 8 is fully filled. You can keep in your mind. 8 is the stable we are talking about. This is fully filled. 4 is half filled. Get my point? This is the stability of an atom. Okay, clear? So fully filled, half filled. Okay, then, so what about the less than 4? How many number of electrons can be said to be?
3.
Maximum 3 electrons can be lost by an atom. Minimum 2 or 1. Okay, so this is said to be the atom's tendency to lose an electron. So for an atom, for losing one electron from it against the nuclear force of attraction, it requires definitely an energy. So that energy is said to be ionization energy. It is also given in your book. Okay, so we'll see that in an elaborate manner after just this class, okay, in your chemistry also. So what is an ionization energy? Ionization energy is the amount of energy required for the atom. Amount of energy required for an atom to lose electron. So the amount of energy required for an atom to lose an electron is ionization energy. Suppose if there is the valency of 3 number of electrons in its outermost, for example, aluminum. We are taking aluminum, it is having 3 valency. That means it may able to lose 3 number of electrons.
Ma'am,
So,
can you please repeat what is that ionization?
the amount of energy required for an atom for an atom to lose electrons. Okay, so that is ionization energy. It's clear?
Yes.
Okay. So you don't think the atom, suppose if there is 3 valency, so it has the ability to lose 3 electrons. You don't think it may lose at a time all the 3 electrons. It may lose one by one. So there must be different levels of ionization energy. First ionization energy, second ionization energy, third ionization energy. Okay. So right now you can learn until this. You're going to learn more about this in detail in your higher classes. Okay. So there are different levels of ionization energies. So that means the atom tends to lose its electron one by one, not at a time 3. So the maximum number of electrons lost by an atom will be 3, but it won't lose all the 3 electrons simultaneously. It may lose one at a time. Get my point? Now, so what is the valency of this sodium?
1.
1. So 1 is the valency. The atomic number is 11. So 1 is the valency. So what is the tendency of this sodium atom?
Tendency to lose 1 electron.
Very good. So if it loses electron, then we may say if there is 11 number of electrons in a sodium atom, okay, there is 11 number of protons also. If the sodium atom is losing 1 electron, then how many number of electrons are remaining in that atom? 10 electrons. There will be 11 protons. So it is rich in 1 proton now. So that we used to call this as ion. If an atom tends to lose electron, then that is an ion. Okay, there is a possibility for, you can write an atom tends to lose electrons is said to be a positive ion. If it loses electron, it is positive ion, or it is known as cation. Since it gets attracted towards cathode, you know cathodes are negatively charged electrode. So you have learned in cells, right? So this is positively charged ion. It gets attracted towards cathode. So the scientists call this name as cation. Since nowadays science is globalized, so you need to come across these names as it is named by the scientist. Okay, you can able to name it in variety of names with your own creativity and idea. But on those days, the scientists have the pattern to name their particular inventions according to their own name or according to their own caliber, they put a name. Clear? So cation is the positively charged ion. Okay, so this thing you have to keep in your mind. Suppose if you talk about chlorine, what is the valency of chlorine? What is the valency of chlorine?
7.
7. 7 is the valency of chlorine. So it is less than half filled or more than half filled?
More than.
More than half filled. So more than half filled means it will accept electrons in order to maintain its stability. See, for example, if sodium atom loses 1 electron, then its outermost will be 8 now. So it attains its stability. Get my point? So that is the idea. That is an atom. The atom tends to maintain its stability. Okay. So sodium atom loses 1 electron and it attains its stability. Then what happened to chlorine atom? Chlorine atom has to accept how many electrons to maintain its stability? Chlorine atom, 1. Very good. So if it accepts 1 electron, then definitely it will be 8 number of electrons. So it maintains its stability. So we may call this as chlorine atom as negatively charged ion. Can we say like this?
Yes, ma'am.
And then it gets attracted towards the anode, which is positively charged electrode. So it is known as anion. Clear? Get my point?
Yes,
Okay.
ma'am.
So keep it in your mind. So if you learn one thing like about cation, the opposite will be the anion. That's all. Okay. So now we'll get into this particular chapter. I'll come into you. So what is the atomic number for copper? 29. What is the
20.
atomic? 29, right. So can you write the octet configuration right now? And let me know the valency. Yeah, that is electronic configuration. I'm asking you to write octet configuration. 888. After 2, you have to split into 8. What is the valency of copper? Twenty-nine can be written as 888 like. Hmm. Are you writing? Hmm? No. No. Hmm?
No, is it 3?
Pardon me? 3 are. So we do not like that. We do not write like that. Here the confusion comes, right? So that you must know the electronic configuration here. Okay, that I have discussed in that video. I will just include this video, okay, in this particular description box, okay. So I'll connect the link to this, and then I'll send you personally also. So its valency is 2 actually. It is explained, it was explained in detail. So I given lot more times about all these things, then I'm getting so bored about this. Okay, anyways, you keep in your mind copper has the valency of 2 plus. It is having the valency 2, so it is said to be copper 2 plus. That means the copper atom has the tendency to lose 2 electrons. Now, what we can say, suppose if you are considering a copper wire, okay, for example, this is if you consider 1 centimeter wire, okay. So, how many number of atoms can you imagine in 1 centimeter of wire? In 1 centimeter of wire,
2 power 10 to the power of 27.
yeah. So, like this, trillions and trillions of atoms, right? Get my point? Okay, so if you are considering 1 centimeter wire, so here you can find trillions and trillions of atoms. The atoms has its own ability to lose electron. Since it is a metal, all metals are electropositive. We used to call that. Since it is a metal, it may lose electron. So after losing electron, it becomes a positive ion. So that we can separate the positive ion, copper 2 plus ion, as a positive charge. So now we are coming to the electricity, static charges. I'm talking about the charges. So the heading you can put how the charges are produced. Okay. Say for example, we have taken copper wire. So we have taken copper wire. Okay. So, and then in 1 centimeter of wire, trillions and trillions of atoms are present. So how the charges are produced, we are going to see. The atom has the tendency to lose 2 electrons. Now, after losing 2 electrons, the copper atom becomes a cation, that is copper 2 plus ion. Now, this copper 2 plus ion is rich in proton. So, we used to call this as positive charge. Okay. So, this is positive charge. And it lost 2 electrons, right? That 2 electrons are said to be negative charge. Now, one atom produce charges, right? Both positive and negative charges. Can you able to understand? Suppose if you are taking 1 centimeter of wire, this is said to be 100% of atom. In this 100% of atoms, not all the 100% of atoms are converted into charges or produced into charges. Okay, so only 60%. So the copper has some behavioral property. So another metal has some behavioral property. Okay, if you talk about sodium, sodium is very less, I mean, number of electrons. So it is having its ability to convert, I mean, to produce charges by only 20%. Sodium produces only 20% of charges. So that it is not recommended for electrical wires. Get my point? Since copper is producing enormous amount of charges, that is 60% of atom is converted into charges. So that we used to say copper is recommended, highly recommended for producing wires. Okay, is it clear for you? Now, I'll getting into this point. So I'm just exaggerating now. I'm cutting a portion of a curved surface area. You have to imagine the wire as a cylindrical wire, solid cylinder. I'm just cutting a portion of CSA, curved surface area. Okay, so out of it, you can say so many positive charges, negative charges, positive charges. Okay, these are all said to be static charges. Okay, how it will be? Suppose, for example, copper atom we are talking about. So first orbit, L shell, M shell, and N shell. We are just considering only the outermost valence electron. So it is 4s2 electron. Okay. So this 2 electrons are said to be valency of this particular copper atom. See, now this is the original copper atom, or we can use to say this is the ground state atom. Suppose if this atom absorbs some energy, for example, if you are connecting this wire to a battery, for example, I'm saying, now this atom attains energy. Okay, from sunlight also it can gain energy. Okay, so if it attains energy, then what will happen? It can't stay in its fourth orbit. Since it is energy level, now when compared to its own energy level, it gain its more energy level. So that means it is having more energies now. It can't stay here. For example, fourth orbit level is 32 electron volt. Now it gains 132 electron volt. So 100 electron volt difference is there. That means more energy. So that it tries to move to its higher orbit. Like, see, this is fourth orbit. This one is 11th orbit, for example. Now this electron get into this 11th orbit. That means the distance between the center, this is the nucleus. So between the nucleus to this is said to be R, and between the nucleus and this is said to be R prime or R1. Now R prime is greater than R. Clear? Very much greater. So it suffers, the 11th orbit electron suffers less nuclear force of attraction. So it can act individually. But it is under the influence of this particular nucleus only. Since it's far away from the nucleus, it won't experience much nuclear force of attraction. Okay. So